Okay, so thank you so much, and good afternoon to all of you. My name is Mohammed Fawad, and the work that I'm going to present is a joint collaboration between two of my universities because I'm a joint doctoral student at Silesian University of Technology, Poland, and the Budapest University of Technology and Economics, Hungary. The work is being done in collaboration with our research partner, Dr. Qian from University of British Columbia, Canada. So basically, the major focus of this research were based on the four major objectives. So the very first one was the development of the bridge models, because the major research focus is a case study from the bridges. So that's why the major focus was on the development of the models. So the modeling of the bridge was done based on the analytical as well as the 3D model. So for the analytical part, we actually done the finite element modeling, and for the 3D part, we did the bridge information modeling using the BIM framework. And the second objective was then based on the finite element analysis, or the finite element modeling, we were able to identify the location of the sensors. So the proposal of the SHM system was a major second objective, which leads to the development of the integration between the structural health monitoring system of the bridges and the building information modeling or the management. And this is achieved using the IoT technology, which leads to the development of the digital twin of the bridge structural health monitoring system, which actually helps us to provide us the automated structural health monitoring of the particular bridge. And then the major focus or the major objective was to develop the immersive bridge digital twin platform using the integration with the augmented reality. So now let's move towards the case study that we have discussed in this research paper. So it's an extradosed concrete bridge, and the modeling was actually done. The BIM model was done in Revit, and the finite element model was done using a novel technique. So basically, we developed the finite element model using the BIM-based finite element modeling technique. So basically, there are two ways that we could have adopted for the development of such particular technique. Which the first one is the direct integration method, but the problem is that in the direct integration method, you actually convert your 3D model directly from the BIM framework to the finite element model. But as we know that there is a level of difference of the level of details between the finite element model and the BIM model. So once we are importing the finite BIM model directly from the BIM framework, so it creates a lot of complexities, and some of the elements which are not compatible with the finite element software creates a problem. That's why it was not a very compatible situation for us. So that's why we actually adopted the indirect integration method, where we use the visual programming language interface using Dynamo scripts, and we converted our 3D model into the set of line, curves, and points. So once we have this the point, lines, and curves, it can be converted into the TXT file, which can be imported to the finite element softwares, and there you can actually perform the finite element analysis. So once we have our finite element model, which is actually BIM-based, so it means that the BIM model or the BIM is actually working as the repository for this particular bridge or for any particular structure. So we developed the structural health monitoring system proposed based on the finite element analysis, which helped us to locate the points where there is a need of installation of the sensor for the proper monitoring of this particular bridge. So we proposed the structural health monitoring system of the bridge, and the sensors were actually installed on the bridge. So in this way, actually, we developed the integration between the BIM technology and the structural health monitoring system. So in this way, we have the ability to visualize the data within the BIM framework, where BIM is not only working as the visualization tool, but also as a data management repository, where we can store the data, manage the data. We can also store the damage information and all the particular information related to this. So once we have this digital model being developed, so we further proceeded with the development of the digital twin. But here we have used a novel technique, like we use the gaming environment. Using the 3D game engine, we actually developed this particular digital twin, which was directly imported from the BIM framework. So once we have the 3D model there in the gaming environment, so the virtual model is being developed using the location of the exact sensor which are installed on the sensor on the physical bridge. Because for the digital twin, actually there is a two-way communication which is actually needed. So once we have the two-way communication established between the physical structure and the virtual counterpart, it means that the physical structure is sending the information based on the installed sensor to the virtual counterpart, and the virtual counterpart, which is the digital twin model, actually process that particular information. Based on that processing, it evaluates the existing condition of the bridge and then sends back this information to the physical system, where we can visualize this particular information and perform the predictive maintenance, and also the decision making can be done. So in this way, our digital twin actually helps to monitor the existing conditions of the bridge. But as mentioned in the major title of this research, that our major aim was to develop the immersive bridge digital twin platform. So, okay, so we have done with the digital twinning of the structural health monitoring system. We have the automated health monitoring parameters, but the major focus of this research is to visualize that particular information. For that purpose, we take the help of the augmented reality system. So that's why we actually use the game engine, because in the game engine, you can actually directly convert that digital twin into an augmented reality application that can be deployed to the augmented reality headset, and the visualization can be performed in the real time. So we did the same, and we were able to evaluate the results, because here you can see that this is the screen of the XR and Microsoft HoloLens, and once the digital twin was converted into augmented reality application, it was deployed to the HoloLens device, and going on site, you can just launch the model, and once the model is launched, you can just straight away navigate to the sensors which are installed on your virtual model. You just click them. It connects you with the physical counterpart, and on the physical model, actually, you can visualize all the information, as you can see here in this particular diagram. So in this way, remotely or on site, the structural health monitoring of the structures can be performed, and it helps not only to provide the detailed information while being on site, but it also helps to visualize the information, which is the major concern when it comes to the structural health monitoring of the bridges. So then are some of the conclusions of this research. Basically, we achieved the two novel results. The first one is the automated finite element model development using the BIM technology, where we recommend the indirect integration approach using Dynamo script. And then in the integration between the structural health monitoring system of the structures and the BIM technology, which we achieved using the IoT tool. And the third one is the development of the immersive bridge digital twin platform, which is actually done using the gamification approach, because we developed it as a game. And when we just turn the game mode on, so you can just click the sensors, it connects you to the real environment, and you can visualize what's happening on your particular structure or on the particular bridge. So that's all about our research. So there are a few papers which have been already published. So if you would like to know more about the published publications, you can just follow me on LinkedIn, or you can just send me the request. I can share the literature. And also there is one publication which is undergoing, which is also concerning this immersive bridge digital twin platform. I hope so it will be available for the literature as well. So thank you so much.